So in this segment we're going to talk about circles and some of the terminology that goes with circles. There's a lot of them, so I just want to have a separate segment just on the terminology, and then we'll talk about them in more detail in other segments. I'm going to be using Geometry Sketchpad to show this to you today, so I just wanted to show a little bit about what it might look like. Down the left hand side here we have some tools that we can use, and across the top we have some items that we can choose from as far as options as to what we want it to do and how we want it to look. So the nice thing about this software is it can do things that other pieces of software can't do, and it moves things and keeps it dynamic. So I'm going to take my circle tool and I just create a circle, and if I grab this dot here I can make the circle whatever size I want, and I can move it around a little bit too. So there's my circle, and we're going to talk about some of the terms that we can have. So this center piece right here, this dot right here that I'm going to label, so I'm going to label it C, and that's going to be the center of my circle, and some call that the origin of the circle. So now that I have my center or my origin, I'm going to take this tool over here on the left hand side, and I'm going to make a line segment from the center right to the very edge, and the whole circle turns red when I know I'm right on the edge, and this allows me to take this circle and I can spin it around anywhere that I want. I can't move it wider, I can make it, and it's stuck to the edge of that circle. So that line segment is called a radius. Interesting thing about a radius is that from the center of the circle, if I do another one to the edge, and another one to the edge, and another one to the edge, it doesn't really matter where I go, they're all going to be the same. So if I make my circle bigger, my computer program allows it to just automatically keeps that all connected. So there's my radius, and I have 3 radii, so that's a plural version of it. So its plural is called radii instead of calling them radiuses. So radii is the plural version of radius. So if I have the computer, the nice thing about this program is if I take this and I ask it to measure the length of that segment, I can see from C to N is going to be 2.26, and I do the same thing for a couple of different segments. And so they all come out to being the same. And if I make my circle get larger, they all grow, and you'll notice that they all stay the same. So it's important for us to remember that our radius is going to be from the center to the edge, and any radius that I choose are all going to be the same length. And this is important to understand because this makes the circle a regular shape, much like a regular polygon, and when it grows proportionally in all the dimensions, so it doesn't become distorted at all. Another cool thing that this program allows me to do is to make a circle that has this as my radius, and so I'm going to try that again. So I have my point and my radius, and I'm going to tell it come up here, construct another circle for me. Now the cool thing is this circle is exactly the same length or size as this circle. And if I make this circle get larger, I make that circle get larger as well, because it's designed from a center with a given radius. So I can make my circle of a specific size that I want. Now these two circles have a special name. Since they're equal in size, we're going to call them congruent circles. So I'm going to leave all the terms along the right hand side here, and if I take from the center of my circle, if I go from the center of my circle to the edge of my circle, that's my radius again. And if I want to make another radius that goes across to the other side, I can make it, but you can see it's not in a nice straight line. So it's bent. And so I need to see if I can create a line that goes all the way across in a nice straight line. And I can do that, and I can create that. And there it is. It's a nice straight line right across, and if I spin this around, it stays going across, and it goes through the center of the circle from one edge to the other. And so that is a special name. It's called a diameter. And the thing we want to make sure that students understand is if I take and I make a radius, and I ask the computer to measure that for me, and I take a look at my diameter, and I ask the computer to measure that for me, we'll notice that my diameter from S to T is twice as long as my radius from Q to R. And it doesn't matter if my circle is big or if my circle is little. The diameter is always going to be twice the size of my radius. And it doesn't matter which radius I use or which diameter I use, the numbers don't change no matter where I go with my picture. If I change the size of my circle, the numbers change, but the relationship does not. So my diameter is the same as 2 of my radiuses, or 2 radii. So we can come up with a formula that goes with that. So we can say that the diameter is equal to 2 radii, or 2r is equal to d. And we'll talk about that later when we talk about other formulas that go along with circles. Now, keeping that diagram the way it is, if I take a segment and I go from the edge to the other edge, is that a diameter? Well, the answer would be no, because it doesn't go through the center of the circle. And so only the ST is my diameter on this one. This one here, from here to here, is not. It has its own special name called a chord. And so we can point out that a chord and a diameter are similar in that they both have 2 endpoints and they're line segments going from an edge to the edge of the circle, but a diameter is a special type of chord. It's a chord that goes specifically through the center of the circle. Other chords do not. So a chord from one edge to the other, but a special chord is called the diameter. If we do the same kind of thing, except instead of drawing a line segment through, we go from one edge of the circle to the other edge of the circle and have it keep going with a line. That line has its own special name to it, no matter where it is. Going from one edge to the other but keep going, that's called a secant. And the secant is a line that goes through the circle at 2 different points. Now, if I take my second point here and bring it up so it's very, very close to my first point, and when it gets to the actual first point, it only touches at one spot. A line that touches at only one spot of my circle has a special name to it. It's not called a secant that touches at 2. A secant that only hits at one particular point on my circle has its special name called a tangent. A tangent. And tangents have very special properties to them as well. And if we take that now across, we can see that that line only touches at one spot, and it has very interesting properties. And we'll talk about those properties in another segment. So that's a tangent, a line that touches a circle at only one place, at one point. So as you can see, we're getting quite a list of terms. That's why I wanted to set up this separate segment. So looking at some more terms, I take my circle here that I can grow with this dot, and I put a dot or a point someplace on that circle. We'll call it U. Now, if I wanted to measure the distance from U all the way around this circle, coming back all the way to U, I could do that with a string, but it'd be kind of hard to do it with a meter stick, something straight. But I could do it with something that bends like a string. That distance around the outside of something could be called a perimeter. When we talked about the distance around the outside of a rectangle or a hexagon or a pentagon, that's called a perimeter. But this circles, since they're kind of unique, have its own special name. So the perimeter of a circle is called a circumference. And in another segment, I'm going to talk about the relationships between circumferences and diameters and radiuses, and that'll be a different separate segment. So I'll modify my diagram a little bit. I still have my circle that can grow, and I've got 2 points on the outside, and now I've created an angle from V to the center out to U. And so I've created an angle inside here. Some people might call it like a Pac-Man or a wedge. And so these all have special names in circles. And so what I've done is I've created something called a central angle, because it goes from the outside edge to the center, which is my vertex of my angle, to the outside edge. So anything that I use as an angle that goes from the outside edge to the center to the outside is called a central angle. There it is. And if I create an angle that goes from those same points to another point to another point, and I create an angle that goes from those points, now I've created another angle now, and here's my angle that moves around my circle, which is very cool. And I can create another angle. Now this angle is not called a central angle because it doesn't go to the center of my circle. This angle that starts from the edge, goes to the other edge, and goes back again to the edge is called an inscribed angle. And later on in another segment I'll show you the relationship between inscribed angles and central angles, which is very cool. Now whenever we create an angle, either a central angle like this or the inscribed angle that I just removed, we produce two arcs. This little curved area here is an arc, and then I have another curved area around the whole outside. So we have two names for these. One's called a minor arc, which is the little one between U and V, so this distance in here, and the other one's called a major arc, which is the big one around the outside. Minor arc and major arc. Now I'll highlight those on the diagram for us. So here's my minor arc in black, and if I change the shape of my position of my arc, you can see that this black line gets larger. As my angle increases, so does my arc increase, and I can measure the arc length as well if I so desired. By highlighting the arc and then going up here and measuring the arc length, and it tells me the distance from U to V and what that's going to be every time. And as I make it larger, it gets larger. So I've shown my diagram here. The black arc here is my minor arc, and its length is 2. And the distance around the outside, the big arc, is my major arc. It's 13. And these two arcs together would have to add up to my circumference, which is 15.45. And as you can see, as I move things around, the circumference doesn't change because I haven't changed the size of my circles, but the numbers change between the pieces. And the two arcs add up to give me my circumference. And finally, when I have this little arc that I've created, I've made this wedge. I could also call it, that also has a name instead of calling it a wedge. And so if I want to do that, I tell it I want to construct the interior piece, and I want to find out what that colored piece is. How big is that colored piece? Since it's a two-dimensional shape, I want to find the area of it. And so if I find that, I could find the area of that segment in here, and that segment has its own name. It's called a sector. And there we have our sector, sometimes called an arc sector, and it's a wedge. It's a whole area inside, so I want to find the area of that. So I would find the length of an arc, and I would find the area of a sector. So there's all the words that go together that are surrounding around circles. I'm sure there's lots of other ones, but for most of our grades that we need all the way up to high school, this covers most of them. And I will do further segments to talk about the details involved with those in other segments.